All right, let's take a look at some of the vocabulary associated with polynomials and some of the basics of working with them. To begin the discussion of what a polynomial is, we have to understand what a monomial is. Okay, so monomial, mono meaning one, and a monomial is defined as a number or the product of a number and variables that are raised to whole number powers. Or whole numbers being 1, 2, 3, 4, 5, 6, 7, like that. So it could be a number, any number that you pick, 3 pi square root of 7, those are all numbers, or the product of a number and variables. So I could have 5x raised to a whole number power. Well, 5x is raised to the first power, so that counts. Square root of 3 times xy cubed. This is a product of a number and variables raised to whole number powers. Okay, and just products, multiplying those things together. So those are some examples of monomials. Okay. Some non-examples of monomials. Well, things that are, if we did square root of x, okay, we have a variable that we're taking the square root of. That doesn't satisfy this definition that we're looking at. If we had x to the 1.7 power, okay, that's no good. 3 over x squared, okay, that's no good. That's not a product, that's a quotient that has our variable in there. Over here on the side, we want to, numbers, 2/3 is a number as well, so that's fine. It's okay to have numbers in the denominator, but not to have variables in the denominator. If we wrote something like x to the negative 3 power, that's not a whole number in the power. Okay, so those are things that are not monomials. A polynomial is when you take one or more monomials and you join them together with addition and subtraction. So anything from our monomial list, in fact, we could, as an example here, let's throw them all in there. 3 plus 2/3 plus pi plus the square root of 7 minus 5x plus the square root of 3 times x times y cubed. Okay, that is a polynomial. We've taken monomials, put them together with addition or subtraction. If any one of those pieces that we added with the addition and subtraction, I'm going to kind of highlight where the addition and subtraction occurred. Okay. If any one of the pieces in between there was not a monomial, then this whole thing would not be a polynomial anymore. Okay. Those individual pieces that are separated there, now I could do some simplifying here. Okay. These individual pieces here are called terms. Okay. So one of the monomials, any one of the monomials in a polynomial is referred to as a term of that polynomial. Okay. Now, these first four have a lot in common because they are just numbers, and so they potentially could be grouped together. If we represented that as a decimal approximation, we could say there's one number or one term because it's just a single constant number, and then we have these other ones that are in there. Okay. I said that because when we get down to this next part, okay, one of the ways that we name polynomials, this is a little bit like the way that you named shapes when you, or triangles in particular in geometry. You could name them by the angles that they had in them. Was it acute? Was it right? Was it obtuse? Was it equiangular? Or you could name them by the side lengths. Was it scalene? Was it isosceles? Was it equilateral? So we can name polynomials in one way by the number of terms that they have. Okay? So this one that we have above here really would be considered a 3-term polynomial because if we combined all the like terms together, right? So the 3, the 2/3, the pi, and the root 7, none of those have variable parts in them. They are just constants. So those are like terms that we could put together as one. And then we have the minus 5x, and then we have the 3xy squared. Okay, so this has 3 terms in it. If it has 1 term, we already said that was called a monomial. If it has 2 terms, it's called a binomial. Okay, bi like bicycle. Bicycle has 2 wheels. Okay, tricycle has 3 wheels. Trinomial is 3 terms. We saw that a lot with our quadratics. Most of our quadratics were trinomials. All right. 3 terms involved there. Okay. We got them by multiplying binomials together. So when we factored a quadratic, we would get things like 3x minus 5 as one of the factors of that, and that is a binomial. If we go beyond that, okay, we used to have more names for that when Latin was a thing that was taught quite a bit, but it's not so much anymore. So once we get past 3 terms, we just call it, for 4 terms, a 4-term polynomial or a 5-term polynomial, or to generalize, if it has n terms, we call it an n-term polynomial. Okay? We don't try to go beyond mono, bi, and tri for those purposes. Okay? So hopefully you're getting that copied down onto your note page there. I've got these on several of these pages. The other way that we can name polynomials is by something called the degree. Okay, those powers that are on the variables make them very different, make them behave very differently. Okay, so a degree of a monomial is the sum of the powers of the variables in the monomial. Okay, so let's try a few here. I'm going to put a 3x. I'm going to put a 5x cubed over 2. I'll make it negative. Let's put a x squared y cubed z. And I think that's probably enough in terms of this. So following this definition, the sum of the powers of the variables in the monomial. Okay, well let's put one more up there. Let's just put a pi. Okay. So the variable is x. Its power, one of our lazy mathematician shortcuts, the power is a 1. We don't have to write it when it is a 1. So the degree here of this monomial is 1. Okay. Here the only variable we have is the x, and its power is 3, so that is a degree 3 monomial. This one we have 3 variables. The powers are 2 and 3 and 1, and it says the sum, so that means add. 2 plus 3 plus 1 is 6. That is a degree 6 monomial. And this one doesn't have a variable, okay, which could be interpreted as it has a variable, but it's to the 0 power, because anything to the 0 power is 1. Or we could say, well, it has 0 variables in it, so this has degree 0. And that's what's meant by degree of a monomial. So when we take that and we move it to, this is the first part that's kind of not intuitive when we get to degree of a polynomial. But later on you will understand exactly why it's defined this way. Okay? So the degree of a polynomial is the largest degree of any one of the terms of the polynomial. Okay? So if I have one of my quadratic trinomials, or my degree, let's go with x squared plus 3x, I guess I'm going 3x squared plus 3x minus 5. Do that as an example. Let's do a 5x to the 4th y minus 6 x squared, y squared, z squared, plus 8 to the 41st power. Okay, so my first one here, the degree of this monomial, if I split this up into its monomials, it's a 3x squared. This is degree 2. This one is degree 1. This one is degree 0. It says it's the largest degree of any of those. The largest one is a 2. So this polynomial has degree 2. Okay. This one, I've got an x to the 5 has degree 0, x to the 4th is a 4, this is a 1, so this term has degree 5. 2 plus 2 plus 2, right, this has degree 6. This I put in here on purpose because people will try to trick you. It's the largest degree of any of the terms. The degree is the sum of the powers of the variables in the monomial. This has no variables in it, so this one is degree 0, and the biggest number in this list is a 6. That's the largest degree of any of the terms in there, so that is degree 6. Beware of people asking you to find the degree of a polynomial that's not a polynomial. They may throw a term in there that is not a monomial, and so degree only is part of the conversation when we are talking about polynomials, which monomial, of course, is a polynomial. Okay. So now that we've established what degree is, we also have a conversation then about naming polynomials by their degree. So we can name them by the number of terms that they have, and we can name them by their degree. If the degree is 0, like we saw in several cases, that's what we call a constant. We talked about the constant term in the quadratic chapter quite a bit. If the degree is 1, it's linear. We spent the first half of the semester talking about linear equations, things where it was just mx plus b, and mx plus b, the x is the only variable, and it is to the first power, and so it is linear. We just came out of several weeks in a quadratic chapter. The powers on our variables were squareds, right? ax squared plus bx plus c, or a times x minus h squared would get the x squared, or when we do the x minus r1 times x minus r2, those x's multiplied together would get squared, and so those were all quadratic. If the degree happens to be 3, it's cubic. Okay, a cube has 3 dimensions, length, width, and height on it, so that name makes sense. Degree 4 is called quartic. Quarter, 4 quarters in a dollar, 4 quarters in a basketball game, right, or a football game at least, depending on what level you're playing. And so 4 makes sense there for quartic. Degree 5 is quintic. You don't necessarily need to remember quintic if you apply the bottom rule to this, where it's a degree in polynomial, so a degree 5 polynomial, degree 7 polynomial, degree 9 polynomial. This polynomial, definitely you may be thinking, I've heard that word before. What you probably heard before was polygon from geometry. Polygon meant many sides. In that figure, polynomial is talking about many terms in the figure, or in the expression. Okay, so when we name something like 3x to the 4th minus 7x to the 5th plus 2x squared minus 5, okay, this is, or I'm going to leave the minus 5 off for now. I'm going to do it like that. This I would call, the degree here is 5, so this is a quintic trinomial. Quintic because it's degree 5, trinomial because there are three terms. Let's throw one more example in there. Let's do, and notice I wrote this one in here. I didn't make it the one that was in front necessarily. We'll talk about that a little bit as well. So negative 2x to the 7th minus 4x to the 6th plus 8x to the 5th plus 2x cubed minus 7x plus 9. Okay. The degree here is 7. I don't have a nice Latin name for that, so I say it's a degree 7. It has 1, 2, 3, 4, 5, 6 terms in there. I don't have a name for that, so it's a degree 7, 6 term, if I can spell term, polynomial. Okay, so we name polynomials by their degree and by their number of terms. Finally, here, like terms are any two or more terms that all have the same variables raised to the same powers. Okay, so if I see something like 7x to the 5th y squared minus 10 y squared x to the 5th, same variables, the variables are raised to the same power. Multiplication can happen in any order anyway, so I could switch these things and make it look exactly like that. And so if I have 7x to the 5th y squareds and I take away 10x to the 5th y squareds, I'm left with negative 3x to the 5th y squareds. Okay, so those are like terms. A counterexample over here, if I had 7x to the 5th y squared minus 10x squared y to the 5th, okay, even though these are both degree 7, the power, and they use the same variables, the powers on those variables are different, so these are completely different things and I can't combine them. I have to leave them just like that. Okay. The only other thing that I want to throw at you, and you can write this in there somewhere, you will often be asked to write your final polynomial in descending order of powers. We talked about a lot of examples today where there were x's and y's and z's and things in there. The reality is what we're actually going to deal with are just going to have one variable that shows up in there. Okay? So if you're looking at something that says 3x cubed minus 5x to the 5th plus 2x minus 19, okay, the preferred way to write this is the biggest degree first. Okay, so my biggest degree is negative 5x to the 5th. My next biggest degree is the 3x cubed, and then the 2x, and then the minus 19. These are the same because adding and subtracting, or adding can be done in any order, and it doesn't change the outcome, but we like these so that we can quickly see what the degree is because it's the first thing that's in there. This becomes what we refer to as the leading term. So this is the leading term of this polynomial, and the negative 5 is called the, let me color code it here. So the leading term is the whole thing, and the negative 5 is the leading coefficient. And we bother defining those things because we will make use of them later. Okay, so those are the things that you need to know. There's the basics of polynomials and the vocabulary associated with it.